Okay, good afternoon, class. All right, so today we are going to start a new chapter, chapter 4, complex number. All right, so look at the analysis table. So far, this chapter haven't come out in part B yet. It's only come out in part 1, part A. All right, and the marks will be like between 9, 11, 10, or 7. In 2019, only 4 marks, and then last year, 10 marks. Right? So it is one of the easy topic lah. Same as chapter 3 matrices. So chapter 3 and chapter 4 you should score, which is they are not too complicated. Alright? Okay, so let's start. Okay, 4.1 complex number in Cartesian form. So for complex number we have two forms. One we call Cartesian form, another one we call polar form. Alright, so we will go through Cartesian form first. Alright, so before this, I have mentioned a little bit about complex number, right? Which represented by I. Okay, now let's go into details. Okay, for any real number, this one we know, non-negative property, right? For any real number, after you square it, it's always more or equals 0. So for example, let's say when x equals 2, so x squared is 4, which is more or equals 0, and x will be square root 4, which is positive 2. Okay, let's say x is negative 3. So x squared will be 9. Again, it is more or equals 0. And x will be square root of 9, which is negative 3. Right? So this is, you see that all for all real numbers, after we square it, it becomes positive. Or more or equals 0, which we call non-negative property. Okay, but if you have a value of x squared which is negative, for example, x squared equals negative 1, then x will be equals to square root negative 1. So what is the value of square root negative 1? Remember I asked you to press your calculator and you get it max error, right? So because this is not a real number. Okay, so square root negative 1 is not a real number and cannot be represented as a point on the real number line. Real number line, you know it, right? Let's say start from 0, 1, 2, negative 1, negative 2. We call this real number line. Alright, so because square root negative 1 is not a real number, so we can't represent it on a real number line. Alright, and square root negative 1 is an imaginary number. We call it imaginary number. Alright, which is denoted by small letter I. So square root negative 1 is actually equals to I. Okay, if I square both sides, I square both sides. So square root and square, you get negative 1. And here is I square. Alright, so you know that I is square root negative 1. So I square will be equals to negative 1. Which we call it an imaginary number. Okay, some other example of the imaginary number. For example, square root negative 4. So I can write as 4 multiplied negative 1, right? Yes, so I can split this one. Square root 4 multiplied with square root negative 1. Alright, so square root 4 is 2. So 2i. This is how we simplify it. Alright, another example. This one. Alright, negative square root negative 75. So I can write it as square root 25 times 3. Alright, 25 times 3 times negative 1, right? Okay, so square root 25 is 5. Square root 3 is third. We write it in the third form. And square root negative 1 is I. So after simplify, we can write in this form. Okay, so do this one. So this one I can write as 4 over 49 multiplied with negative 1. So square root 4 is 2, square root 49 is 7, and square root negative 1 is I. So this one will be equal to 2 over 7 I. Alright? Okay, so in general, an imaginary number is of the form AI. See? AI. AI. Where A can be any real number. So this is how, in generally, how we simplify it. Okay? And number 4, imaginary number can be added to or subtracted from other imaginary numbers. We can add or subtract them if both terms are imaginary number. For example, 2i plus 5i, so together 7i. Square root 7i minus 1i, so we cannot square root 7 will be a decimal, right? And we don't want to express it in the decimal. So what you can do is we factorize out the real number part. Square root 7 minus 1, then I we put outside. So this is how we write it in the simpler form. Okay? Number 5, the product or quotient of two imaginary number is real. Means that if we add or subtract two imaginary numbers, the answer still imaginary numbers. But if we multiply or if we divide two imaginary numbers, then the answer become a real number. Alright, so how we do it? Okay, let's see one example. 2i times 5i. So 2 times 5 is 10. I times I is I squared. Alright, so what is I squared? See, just how we already say I squared equals to negative 1, right? So 10 multiplied negative 1, negative 10. So you see, when we multiply two imaginary numbers, it becomes a real number. Okay, so to divide. So 6i over 3i. Divide ma. So I and I can be simplified. So the answer is 2. Okay? Alright, so number 6, we will see the power of I. The power of I also can be simplified. So we start with I. We know that I is square root negative 1. So I square. When we square this one, I square is negative 1. Okay, how about I cube? Okay, I cube I can write as I square multiply I. Alright? And I square is negative 1 multiply I. So I cube is equals to negative I. Alright? And I power 4. So I power 4 I can write as I square multiply I square. Alright? And we know that I square is negative 1. So negative 1 multiplied negative 1, the answer is 1. Alright? Okay. Okay, the next one. I to the power of negative 1. I power negative 1 means 1 over I. Alright? I remember before this, I also already explained to you. Just like the third number. Remember? Just like the third number. Last time I told you that we don't want, if an answer is in third form, we don't want the denominator in third form. So we multiply third 2 over third 2. So that it become like this. Or we rationalize the denominator. Remember? For third number. Okay, so we are going to do the same thing to imaginary number. If the denominator is imaginary number, so what we can do is we multiply I over I. Alright? So 1 multiply I is I. I multiply I square. And again, what is I square? I square is negative 1, right? So this one is negative 1. So means that negative I. Right? So I to the power of negative 1 is equals to negative I. Alright? Okay. So, for example, 4.18. Simplify all this. I want you to go back and try as homework lah. Okay? Try it as homework. If you have any question, can WhatsApp to me. Alright? Then next, number 7. The sum of a real number x with an imaginary number yi, alright, result in a number in the form of x plus yi. Means a real number add to an imaginary number, alright, which we cannot simplify anymore. Then we call this number as complex number. This is complex number in the Cartesian form. Alright, so I remind again, if only AI, then we call it imaginary number. if it is the sum of one real number and one imaginary number, then we call this whole thing complex number. All right, and this is in the Cartesian form. Why Cartesian? Because it involves xy. All right, later we will see. It can represent by on the Cartesian plan. We call it imaginary Cartesian plan. Okay, so these are some example of complex number, like 2 plus 3i. So this is real part, this is imaginary part. 4 minus 7i, minus 1 plus 4i. All right. Okay, then the set of the complex number. This is the symbol for the complex number. All right, this is the symbol for the complex number. A C, then a vertical line like this. All right, so a complex number cannot be represented as a, the set of complex number is defined as this one. So complex number is Z. Z is x plus yi, with both x and y are real number, but I is an imaginary number. All right, so a complex number cannot be represented as a point on the real number line. Remember just now I said the real number line? Okay, so hence complex number do not obey the rules on order. Means that sometimes some rules that obey by the real number does not obey to this complex number. For example, for two complex number, let's say I have two complex numbers, Z1 and Z2. So Z1 less than Z2 is actually meaningless. No meaning. Because only real number that we can represent it on the real number line. Then we have the concept that, okay, 1 is smaller than 2. Negative 2 is smaller than negative 1. Real number has this concept. But because imaginary number cannot represent by the real number line, so the concept that which one is smaller than which one is actually meaningless. Means that we won't compare two complex number which is bigger or which is smaller. All right? Okay, number 10. So if y equals 0, in a complex number, if y equals 0, means this part becomes 0. Then z equals x, right? And it becomes a real number. All right? Hence, the set of real number R is actually the subset of the set of complex number. All right? So it is in this set form. The smaller set is n. Still remember n? The natural number. Start with 0, 1, 2, 3. Natural number. Then followed by z. All right? Z is all the integers, included negative. This one positive and 0 only. This one included negative integer. All right? Then followed by the set of Q. Okay? Q is, we call it, included something like fraction. All right? Something like fraction. Decimal. Okay? And then in real number line, so biggest one is actually R, all the real number. All the real number included cert to decimal, fraction, integers, everything. Everything. All right? And now after you have learned complex number, actually complex number is the bigger set. All right? It's a bigger set, included R. Why? It's like what I said just now. If a complex number, if the y part is 0, so this complex number can be a real number when the y is equal 0. Therefore, R is actually subset of the complex number. All right? So this is the concept. All right. So since x plus yi is a complex number, all right? Two parts, right? Two terms. Then x, we call it real part or real terms. All right? And yi, we call it imaginary part or imaginary terms. All right? So the real terms is given first, even it is negative. So means that when you write a complex number, no matter what, you write the real number first, even though it is negative. Because before this, remember, I always mentioned that if the first term is negative, we put it at the back. So that it looks neat. All right? But not for complex number. All right? Complex number, no matter what, we write the real part first, then followed by the imaginary part. Okay? And number 12. If a complex number z equals x plus yi is a complex number, then the real part x can be denoted by REZ, the real part of complex number z, which we write as x. Alright, and the imaginary part yi can be denoted by IM, imaginary part IM. IM of z is y. Okay, real part and imaginary part. It will ask in STPM, they will ask you to form a complex number, then state the real part and the imaginary part. Yes, it came out in STPM before. Alright, so here are some special cases. Okay, if b equals 0, or let's say I have a complex number a plus bi. If b equals 0, this one's 0. Alright, then this complex number become a, which is a real number. How about if a equals 0? Or if this is the complex number, if a equals 0, then the complex number become bi. Then it become imaginary number. Alright, and if a 0 and b also 0, both also 0 in here. Okay, then a plus bi equals 0 only. Then we call this 0 complex number. So we only have 0 complex number if and only if a 0 and b 0. Okay? Alright, so let's see some example. Example 4.1b. So express each of the following in the form a plus bi. So remember, a plus bi, we call it Cartesian form. Okay, so let's look at it. I do it here. So question A, 4 plus square root negative 81. So as I say, square root negative 81, I can write as 81 multiply negative 1. Alright, square root 81 is 9. Square root negative 1, I. This is how we write it in Cartesian form. Alright, then B. Negative 3 minus square root negative 98. Alright, so of course 98 is not a perfect square, but 98 is 49 times 2. Alright, 98 is 49 times 2, and the negative, I multiply negative 1. Alright, okay, so it becomes negative 3 minus, alright, so this is, square root 49 is 7. Square root 2, I just write insert form. We normally express it in insert form. We don't want decimal. For complex number, we seldom use decimal unless it's related to anchor. Later we will discuss about anchor. Alright, and square root negative 1 is I. Okay, so I hope it's very clear.
Can see, okay. Can see, right?
Okay, alright. Okay, so now we have learned the concept, the basic concept of complex number. Okay, now we see some operation on complex number. 4.2, elementary operation on complex number. So, dual operation of plus, minus, multiply, and divide on real number can be extended on the complex number. Means all these 4 operations, we also can do it to the complex number, but slightly different the way, especially in division. Alright, so 4.2.1, addition and subtraction. This one very simple. When combining complex number using this operation, so the real terms and the imaginary terms are separated into 2 groups. Means the real one will add the real one, the imaginary will add to the imaginary. Alright, it is actually very simple. Okay, so this is one example. So let's say Z is a complex number x plus yi. W is another complex number u plus vi. Alright, so how to add Z to W? Very simple. Z is x plus yi plus W is u plus vi. Alright, so as I said, real part add to real part. So x plus u. We write it in a bracket lah, easier to see. Alright, plus imaginary plus imaginary. So yi plus vi. So we factorize out y plus v, then the I we can write outside. Oh, it's just that simple. Okay? So how about subtract? Alright, subtract all those the same. So z is x plus yi minus W is U plus VI. Alright, so the same, real part to real part. So X minus U. This is a real part. Okay, so the next one will be plus. I still write a plus. It's actually YI minus VI, right? YI minus VI. So I write Y minus VI. Center here is still plus lah. Okay? So this is how we add and subtract two complex number. Okay, here are two examples. Very simple. 3 plus 4i plus 5 minus 6i. So real part to real part. So 3 plus 5, 8. Alright, imaginary with imaginary. So 4i minus 6i. So negative 2i. That's it. Alright, so this one is subtract. So 5 minus 8, negative 3. Okay, minus 3i minus 2i. So minus 5i. Okay, plus and minus, very simple. Okay, so the next one will be multiplication. Alright, to multiply two complex number. Okay, so to multiply two complex number. Alright, to multiply two complex number, very simple. We do like something like quadratic. We expand them something like quadratic. So the distributive law of multiplication apply to two complex number. Distributive law. So I hope you still remember what is distributive law. Something like this. Let's say A, B plus C. So A multiply B plus A multiply C. Distributive law. Okay? So let's see some example. 2 plus 3i is a complex number. 4 minus 2i, another complex number. So how we multiply them? Very simple. Use the first term, multiply both here. So 2 multiplied 4, 8. 2 multiplied negative 2i, negative 4i. Alright, then use the second term to multiply them also. So 3i multiplied 4i, 12i. 12i. And 3i multiplied negative 2i. 3i multiplied negative 2i. Okay, 3 multiplied negative 2 is negative 6. Alright, I multiply I square. Right? Okay. What is I square? Remember? I square is negative 1. So this one become plus 6 lah. Okay, so we see the real part. 8 plus 6, 14. Then imaginary part, minus 4i plus 12i plus 8i. Yes, this is how we multiply them. Alright, just like you expand the quadratic. Just be very careful. When I multiply I, yes, it's I square. And I square is equals negative 1. Okay? Alright, so I want to try this one as homework lah. You try this. No, it's okay. I will show this one. 2 plus 4i, 2 minus 4i. So same. 2 times 2, 4. 2 times negative 4i, negative 8i. Alright, then second term. 4i times 2, 8i. 4i times negative 4i, 4 times negative 4, negative 16, and I square. I and I, so I square. Alright? And remember I square is negative 1. So this one become plus 16 already. So 4 plus 16, 20. What is negative 8i plus 8i? No more. No more I. So the answer is a real number, 20. Okay? So note, the product in the second example is a real number. This one, the answer for the second one become a real number. This is because of the special form of the given complex number, which is a 2 plus minus 4i. You see? 2 plus 4i, 2 minus 4i. I hope you still remember insert form. We have learned conjugate. Yes, this is also conjugate for complex number. Alright, so when Z is A plus BI, where W is A minus BI, you see both also A and BI, 1 plus, 1 minus. Then when we multiply these two pair, A to A square, A to negative BI, BIA, this one B square, by right is minus BI square, BI ma. So again, minus ABI plus ABI, no more. So A square plus, why plus? Because I square is negative 1. Negative 1, that's why become plus. Alright? So W is known as the complex conjugate of Z. And we can write as Z star or Z bar. Both can. Alright? Some books or even in exam, sometimes they use Z star, sometimes they use Z bar to represent the conjugate. Alright? So remember, when you multiplied a complex number with its conjugate, a complex number multiplied to its conjugate, you don't have to do the long expansion like this. You don't have to do the long expansion like this. What you can do, you can straight away apply this formula. A square plus B square. So I hope you don't confuse one thing. Remember, for quadratic for real number only quadratic, when we have A plus B, A minus B, we know that it's equals to A square minus B square. Remember, this is for real number. When you have A square minus B square, it becomes A plus B, A minus B. It's also conjugate, but for real number. Alright? So for complex number, when you have A plus BI multiply A minus BI, so remember it becomes A square plus B square. Why plus? Because of the I square equals negative 1. So I hope you don't confuse about these two concepts. Hold on, Yeah, I hope you don't confuse about these two concepts. This is for real number. So it's A square minus B square. This is for complex number. So it becomes A square plus B square. Alright? Okay, and the law of surd cannot be applied on imaginary number. So remember when we learn surd, if I have surd A multiplied surd B, I can combine them become like this. Surd A multiplied B. But if you have surd negative A multiplied surd negative B, you cannot combine them like this. Okay, cannot. Because when you combine this, it becomes positive. So this is still real number. But where else we know that this is actually complex number. This is also actually complex number. Alright? So let's use one example to see it clearly. Alright, so this is square root negative 4 multiplied square root negative 9. You cannot do this. When you do this, it actually becomes square root 36, which is 6, which is a real number. Alright? But actual, what happened is like this, right? Because square root negative 4 is actually 2i. Square root negative 9 is actually 3i. Right? So 2i times 3i, 2 times 3 is 6. I times I is I squared. Still remember what is I squared? Yes, I squared is negative 1. So the actual answer is negative 6 and not 6. Alright? This is the meaning. The law of the surd cannot apply in imaginary number. So do division. Alright? For real number, we can write like this. But for complex number, cannot. Okay? So this is for multiplication and this is until multiplication. Alright? Because division is different. Division is different thing. Alright? Okay. Alright, so next what I want to discuss is example 4.2.2. Alright, express each of the following in the form of A plus BI. Okay, this one I want you to do at home as homework. Okay? Do it as your homework. Just multiply only. Alright? Just be careful when you have I square. Okay, I will go to question 2. Okay, so I will go to question 2. Let's say if z is x plus yi, w is u plus vi. Alright, show that x plus w conjugate of x plus w. So x plus w is another new complex number. The conjugate of this new complex number actually same as conjugate of z plus conjugate of w. They want us to show this one. And also zw, the product, when you multiply, this is become a new complex number. So the conjugate of this new complex number same as conjugate the z multiplied conjugate w. Alright, this is what they want us to show. Okay, so the solution is like this lah. Okay, this is z, x plus yi, and w, u plus vi. Okay, z plus w means x plus as we said just now, real part plus real part, so x plus u. Imaginary plus imaginary, so u plus v, and I are factorized out. Okay, so this is z plus w, is a new complex number, and its conjugate, alright, each conjugate will be the first two terms, the real and imaginary part exactly the same, just plus become minus. Alright, then this is z, so the conjugate of z is x minus ui lah, and this is w, so the conjugate of w is u minus vi lah. Okay, so we find this new complex number, conjugate z plus conjugate w. So this one plus this one, so same, real part plus real part, x plus u. Then it's minus, right? So I minus, then I factorize. It's actually minus y minus v. So I factorize out minus, become y plus vi. So when you compare, is it same? Yes, it's exactly the same, right? Therefore, we already shown actually conjugate of z plus conjugate of w same as conjugate of z plus w. Okay? Alright, so this part I want you to do as homework. You do the similar thing. Try it at home. How to show this one? You find zw first, then write the conjugate. Then you multiply the conjugate of z to conjugate of w. And you compare the answer like this. Alright? Okay, then we go to question number 3. Remember just now I said complex number can be expressed in two forms. X plus yi, we call it Cartesian form. Alright, and another one I say it is polar form. This is polar form. In cos and sine. In terms of cos and sine. This is polar form. So later we will go to polar form. So now just example only lah. Alright, so they want us to find the answer for this one in Cartesian form lah. Okay, so I show you B, because B is cube lah. So this one you do as homework. 3A you do as homework. Alright, I will show you B. Okay, cos pi over 3 plus I sine pi over 3. If it is in polar form, we can write the I here lah, so that you won't confuse with the anchor. Alright, so it is cube. So we use binomial theorem. Remember binomial theorem? If power 3 means you must have 4 terms. 1, 2, 3, 4. And the coefficient is 1, 3, 3, 1. Still remember? So before this, I write it in the form of real number first. So pi over 3 is 60. So cos 60 is half. Sine 60 is square root 3 over 2. I put back here. So first term, cube. Alright? So the power for 1 over 2 decrease. The power for the second term increase. Decrease. Increase. And at the end, power 3. Alright? So this one, cube is 1 over 8. This one. Alright? This is 1 over 4. So 4 times 2, 8. So 3 times square root 3. So I. Alright? This one. This one square is 3 lor. This is 4 lor. So 4 times 2, 8. This one square is 3 ma. So 3 times 3, 9. Alright? I square. I square. I square is negative 1. Therefore, it become negative. Alright? No more I. And last one is this lah. So square root 3 over 2 cube means, so when square root 3 square is 3. So left one more. So this is 8. Okay? This is how I get this. And I cube. See, remember I cube? I cube is I square, I. I square is negative 1. So it's negative I. Therefore, it becomes negative I. Alright? So you see, this and this are the same term. 1 plus, 1 minus, so no more. So 1 over 8 minus 9 over 8. So negative 1. Okay, so this is polar form. After we express in Cartesian form, it's actually a real number, negative 1. And actually negative 1, you can write as negative 1 plus 0, I. But not necessary lah. So this is in Cartesian form. Alright? Okay. So plus, minus, multiply, not difficult. Alright? And not really special. Okay, so now we will go to division. Yes, division. Division slightly different. And you see that there are some partial questions here already that involve division. Alright? Okay, so the division of any number by a complex number can be done if the denominator is transformed into a real number. We must transform the denominator into a real number. And how to transform it? So this process is called realizing the denominator. Change it become real number. How to change it become real number? Very simple. Just multiply the numerator and the denominator by the conjugate of the denominator. Why conjugate? Come back to this one. Remember, when a complex number multiplied with a conjugate, then you get a real number. We are using this concept. Okay? So let's see some example. Example 4.2.3. Question 1. So there are 4 questions here. I will discuss 2. Another 2, you will do it as your homework.
Can see? Alright, can. Alright? Here. Here can.
Here also can. Alright. Okay. So question 1A. Express each of the following in the form of A plus BI. In a simplest Cartesian form. Okay, so the first one, 3 plus 4i divide 2 plus 3i. 3 plus 4i divide 2 plus 3i. So remember, we are going to realizing the denominator. We multiply the conjugate. This is 2 plus 3i. So the conjugate is 2 minus 3i. So 2 minus 3i over 2 minus 3i. This is 1, right? This is actually equals to 1. So we didn't change the question. Alright? So denominator, very simple. A complex number multiplied with its conjugate. The answer is 2 square plus 3 square. No matter what minus. Just use a formula. This one you express like quadratic. 3 times 2, 6. 3 times negative 3i, negative 9i. 4i times 2, 8i. 4i times negative 3i. So negative 12i squared. Alright, so denominator 4 plus 9, 13. Real number, this one, I squared equals negative 1, right? So this is actually plus 12. So 6 plus 12, 18. Minus 9i plus 8i minus 1i. Don't leave it in this form. The question 1, A plus BI. So you split it into 18 over 13 minus 1 over 13i. Final one in this one, not in this one. Alright? Yeah, this is the simplest one. Okay, B. 1 plus I over 2 plus I and square. So when you have square, you cannot direct multiply with the conjugate. You must elaborate first. Numerator we copy. So to express this one, first term square. I also square. Remember, I square is negative 1. Then 2 multiply I. So 4i. Okay? So 4 minus 1, 3. So the denominator is 3 plus 4i. Then only you multiply the conjugate over conjugate. This one plus, so the conjugate minus. Alright, so denominator when multiplied with the conjugate is 3 squared plus 4 squared, or 3, 4. Okay, this one as usual, 1 times 3 is 3. 1 times minus 4i, minus 4i. I times 3, 3i. I times negative 4, I, so negative 4, I squared. I squared is negative 1, so plus 4. Just now I show you again in this form. Now no need, you can directly write. Okay? So this is 25. Alright, real part 3 plus 4, so 7 over 25. Imaginary part minus 4i plus 3i minus 1i, so minus 1 over 25i. Okay? Is that clear? Alright, so C and D you do as homework. C, you combine first. Remember how to combine two fractions? You combine, then only you multiply the conjugate. Alright, this one also you combine. But when you combine, you see it's actually conjugate already. Okay, so you can try C and D on your own. Okay, question 2. I want you to do question 2 as quiz. Alright, after this lesson finish, you immediately do this quiz. Okay, and snap and put it into the Google Drive that I will send to you later. The Google Drive special for chapter 4. Alright? Okay, so now I will discuss 2 past year questions. Let's see how the question can ask. I will discuss 3 and 4. You do question 2. Okay, question 3, SCPM 1999. Determine the value of A if this complex number is a real number. Okay, then find this real number, 4 marks. Or find A if this is a real number. So what does this mean? Very simple. So this is a question. This is a complex number given to us. Alright, so when you see divide, definitely the next step is conjugate. Alright, I multiply conjugate over conjugate. This one plus, this one minus. Alright, so the denominator, 1 square plus square root 2 square. This one as usual, square root 2. Square root 2 multiplied square root 2 is 2, so minus 2i. This one ai, and this one, a square root 2. I square is negative 1, therefore negative 1 plus. Alright, then the real part, this one is 3 3. 3 3. Okay, so real part is this one and this one. So square root 2 plus a square root 2 over 3. Real part. Imaginary part is this one. This is minus 2, this is a, so I write a minus 2 lah. A minus 2i over 3. So after I simplify it in a plus bi form, or in Cartesian form. Okay, and the question tell you that this is a real number. So the meaning of this is a real number means this part equal to 0. 3. Okay, so if it is a real number means no imaginary part. No imaginary part. So how to make imaginary part disappear? This one equals 0. Alright, so when you solve this, you get a equals 2. Find the value of a. So a equals 2. And what is this real number? This is a real number. This is a real number. Okay, so sub a equals 2 into this real number. So 1 sub 2 plus 2 sub 2 is 3 sub 2 over 3. So simplify. So this is a real number. Means this one is actually equals to square root 2. This one is actually equals to square root 2. Sorry, wrong. This one. Okay, this one is equals to square root. This whole thing is equals to square root 2. So a question like this give you 4 marks. Alright, okay, so I discuss one more past year question, which is STPM 2015. Okay, so STPM 2015 say the complex numbers z and w are given by this. So z is minus 1 plus I in Cartesian form, and w is I plus z, 1 minus iz. Okay, So the question wants you to find W in the form of x plus yi. Find in the Cartesian form, where x, y are real number. Then state the real and imaginary part of W. Remember just now I said they will ask you to mention what is the real part and what is the imaginary part. Okay, so the solution will be like this.
See? Okay.
The solution will be like this. This is your Z. Okay, this is W. So the question wants us to find W, right? So W is I plus Z. This is your Z. 1 minus I, Z. This is your Z. Alright, simplify first. So minus 1, I plus I, 2I. This one, 1 minus I multiplied negative 1 plus I, plus I. So plus I. Minus I multiply I, negative I square. Negative I square. I square is negative 1. So negative I square, positive 1. So 1 plus 1, 2. Alright, so the denominator simplified like this. Then only we multiply conjugate. Alright, so multiply with conjugate, denominator 2 square plus 1 square. This one expand as usual. Negative 2 plus I, 4I plus 2. Because I square is negative 1. Then simplify. So this is 5. Minus 2 plus 2, no more. I plus 4I, 5I. 5 and 5 simplified. So your W is actually I. W is just I. Alright? And actually, I can write as 0 plus I. Okay? It's just that we omit this only. If we really like write in the complete way, it's like this. But this one is okay already. So remember just now the question say, state the real and imaginary part of W. So write the symbol. Real part of W is 0. This is the real part, 0. And imaginary part of W is 1, 1i. Alright, so a simple question like this give you 3 marks. There is other part. This is only one of the part. Okay, so what I need you to do today, after this lesson, immediately please do question 2 as quiz. Alright, forward your solution to the Google Drive. Alright, then you complete all homeworks. Checkpoint 4.1, question 1 to 4 and question 6 and other question that I ask you to do as homework. Alright, okay, so tomorrow I will send another video for the next lesson. I hope that within this week we can complete this chapter. Alright, okay, thank you class.